Hi everyone. Today we're going to study primary and secondary data. Every day we come across a lot of information in the form of facts, numerical figures, tables, graphs, etc. These are provided by newspapers, televisions, magazines, and other means of communication. This may be related to cricket batting or bowling averages, profits of a company, temperatures of cities, expenditures in various sectors of a 5-year plan, polling results, and so on. These facts or figures, which are numerical or otherwise, collected with a definite purpose, are called data. Data is the plural form of the Latin word datum. Now let's go to primary and secondary data. When the information is collected by the investigator herself or himself with a definite objective in her or his mind, the data obtained is called primary data. Examples: interview, survey, direct observation, etc. Now, when the information gathered came from a source which already had the information stored, the data obtained is called secondary data. Such data, which has been collected by someone else in another context, needs to be used with great care, ensuring that the source is reliable. Examples: school records, government registration data, resource speaker, etc. Hi everyone. Today we're going to study data collection. Let us define data collection. Data collection is the procedure of collecting, measuring, and analyzing accurate insights for research using standard validated techniques. A researcher can evaluate hypotheses on the basis of collected data. In most cases, data collection is the primary and most important step for research, irrespective of the field of research. The approach of data collection is different for different fields of study, depending on the required information. Let's go now to methods of data collection. The first method is telephone survey. In here, researchers contact respondents via telephone to conduct an interview by asking the respondents a list of predetermined questions. Some of the advantages are: there is wide geographic access. This is also cost and time efficiency. and this is convenient to both researcher and respondent. Here are some of the disadvantages. This method cannot be self-administered. Sometimes it is hard to make a connection. Also, there is limited complexity of questions. The second method, mailed questionnaire survey. The researcher sends set of questions to respondents through mail. Here are the advantages. It can cover large geographic area. Respondents can send response at convenient time. 30% returns is acceptable. It facilitates depth interviewing. Here are some of the disadvantages of this method. This is expensive with regard to postal charges. There is chance of data errors from respondents. There is also lag time of returns. There are less number of returns. The third method is personal interview. The researcher is in a face-to-face conversation with respondent to collect information. Here are the advantages: in-depth and a high degree of confidence on the data. The researcher is able to probe, clarify, or follow up question. The researcher has the glimpse into respondents' tone or gestures. With regard to disadvantages, here is the list. This is expensive. This is impractical for large number of respondents. This method requires skills on the part of the researcher. There is difficulty in making appointment with the respondent. Also, this is time consuming. The fourth method, internet-based survey. In here, researcher floats online survey and respondents respond on that same platform. Here are the advantages. Number 1, cheap, can self-administer, very low probability of data errors, requires less time to collect data, privacy and anonymity of respondents is secured. This is also convenient on both researcher and respondent. For the disadvantages, there is unavailability of respondent's email address or unavailability of respondents on the internet. Customers may be wary of divulging information online. There is lower response rate. There is chance of technical problems. In summary, we studied in this video the methods of data collection. And these methods are telephone survey, mailed questionnaire survey, personal interview, and internet-based survey. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study organizing data. That is, we will study frequency distribution. First, let us define some terms. The first term is ungrouped data. It means the data is raw. That is, it's not sorted into categories or groups. Second term is frequency. Frequency is the number of times a value of the data occurs. Next term is the relative frequency. It is the ratio, fraction or proportion of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. The formula will be like this. Rf equals f over n times 100, where f is the frequency and this n is the total number of frequency. Next term is cumulative relative frequency. It is the accumulation of the previous relative frequencies. To find the cumulative relative frequencies, add all the previous relative frequencies to the relative frequency for the current row. And the last term is grouped data. In this case, the data is grouped into classes. There are steps in constructing frequency distribution. Step 1, we will make a table as shown. It means there will be 5 columns. For step 2, arrange data value in ascending order and place it in column A, that is for ungrouped data. Step 3, tally and count the data and place it in column B and C. Step 4, find the relative frequency of values in each class by the formula Rf equals f over n times 100. Step 5, add all the previous relative frequencies to the relative frequency for the current row. Let us see example 1. 20 students were asked how many hours they worked per day. Their responses in hours are as follows. These are the data. Construct frequency distribution. First, let's have our step 1, and that is to make a table with 5 columns. In step 2, we will arrange data value in ascending order. So we have data starting from 2, 3, 4, 5, 6, and 7. For step 3, we will tally each raw data in the dataset and put in the corresponding data value in our tally column. So in here, it means 3 times the number 2 appears in our data set. The same is true with number 3, 5 times it appears. For number 4, 3 times, and so on and so forth. For the frequency column, we will simply count the tally. So it means to say, for number 2, 3 times it appears, so we will write here 3. So for number 3, it is 5, so we write here 5. For number 4, there are 3 tallies, so we write here 3, and so on and so forth. And then we will take the total, and this is now equal to 20. This 20 must be the same with how it is described in our problem. So it's written here 20 also. Now, for step 4, find the relative frequency of values in each class. Let's begin with our first row. Using our formula, we have this frequency 3. We will write here over 20, that is the total frequency, times 100. And the answer is 15. And this 15 we will copy in here. Using the same formula, we will fill all the blanks here, and here we go. We have now the relative frequency percentage for each rows. And the total of the relative frequency percentage must be 100. Now, for step 5, add all the previous relative frequencies to the relative frequency for the current row. Okay, let us begin with the first row. This number 15 we will copy here, and for the next value we will add this 15 with this 25. So 15 plus 25 will be 40. Then 40 plus 15 will be 55. 55 plus 30 is 85. 85 plus 10 is 95. And 95 plus 5 is 100. The last entry of the cumulative relative frequency column is 100, indicating that 100% of the data has been accumulated. So, we are done with our example 1. This is now our answer. Remember, because of rounding, the relative frequency column may not always sum up to 100. And the last entry in the cumulative relative frequency column may not be 100. However, They each should be close to 100. Let us have example 2. This time for grouped data. The table represents the heights in inches of a sample of 100 males semi-professional soccer players. Find relative frequency and cumulative relative frequency for the frequency distribution. This is now the given table. Now, let us write our step 1. For our table here, we are going to write 4 columns. In our first column, the heights are there and we can see the classes. The frequency is here on the second column and it is already given. So we don't need the tally column now. Next, we're going to find the total of the frequency, and this is equal to 100. This is based on how it is described in the problem that there must be 100 male players. Next is the relative frequency. This time, we are going to use this formula to express and show that relative frequency can be decimals also. Let's begin with our first blank. So RF equals the F, and that is the 5, over the N, which is 100. And the quotient is 0.05. We will copy this value in the first row. Next, we're going to fill in the full columns. Using our formula, we will have 0.03 in the second row, 0.15 on the third, 0.40 in the fourth, so on and so forth. If we get the total of this, we will get a whole number 1. Next, we will now fill in the cumulative relative frequency. For our first row, we will simply copy this 0.05. For the second row, we will add the 0.05 to the 0.03. So we have 0.08. And that pattern we will follow. 0.08 is added to 0.15, and that is 0.23. The 0.23 plus 0.40 will get 0.63. 0.63 plus 0.17, we will have this 0.80. 0.80 plus 0.12, we will get 0.92. The 0.92 plus 0.07 will have the 0.99. 0.99 plus 0.01 equals 1. So this is now the final answer. Remember, because of rounding, the relative frequency column may not always sum up to 1. And the last entry in the cumulative relative frequency column may not be 1. However, they each should be close to 1. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study categorical frequency distribution. Categorical frequency distribution is a representation of data in tabular form showing categories with corresponding frequencies. Here are the steps on how to construct categorical frequency distribution. Step 1. List all categories in a column. Step 2. Tally raw data to corresponding categories. Step 3. Write the frequency for respective category with respect to tallies. Let us see one example here. 35 Army cadets were given a blood test to determine their blood type. The data set is given here. Construct a frequency distribution for the data. Complete the table below. In our table, we have 4 columns. The first column is for the category, which is the blood type. We can see here there are 4 blood types. We have A, O, B, AB, respectively. The next column is for tally, followed by another column for frequency. There is a column also for relative frequency. Now, let us begin with our tallying of the raw data. Let's begin with our first datum, that is A. We're going to tally this value in the column tally opposite category A. So we have here the tally, and we will strike out that first datum to be sure that we will not repeat that same datum again. This striking out of datum we will do on every raw data here. And to summarize, we have now the complete list of tally of our data set. And then let us go to the next column. This is for the frequency. We will simply count the tallies for each blood type. So for our first blank, this is for the blood type A. So we have 8. For the next, we have 14. And this is for the blood type O. The next frequency is 8 for blood type B. And the next is 5 for blood type AB. And then, let us compute for the summation. We will take the sum of all the frequencies, and this is equal to 35. This number must be equal to the number of data in our data set. The next is, let us fill in the relative frequency column. The formula is given here. RF, that stands for relative frequency, equals F, that is the frequency, over N, that is the total of the frequencies, times 100. So for the first blank, we're going to have this number 8 divided by 35 times 100. And this is equal to 22.9. This value we will copy on the first blank. So there we go. And then we will use this same formula to compute for our remaining relative frequency. So we have this number 40. It comes from 14 divided by 35 times 100. This 22.9 here is the same with our relative frequency of the blood type A because they have the same frequency. So we use the same computation. Now, the 14.2 comes when we have this 5 divided by 35 times 100. And then let us take the summation of the relative frequency, and this must be equal to 100. By the way, the relative frequency of each category describes the frequency of the category in relation to the total frequency. And this is our final answer. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study bar charts and pie charts. Let's begin with bar charts. Bar charts, or sometimes called bar graphs or bar diagrams, are used to represent categorical data. Bar graphs consist of bars that are separated from each other. The bars can be rectangles or they can be rectangular boxes used in three-dimensional plots, and they can be vertical or horizontal. These are steps to construct bar charts. Step 1. Draw a horizontal line and assign it to category, and vertical line for the frequency. Step 2. Represent each item in category by rectangles of equal width and height corresponding to its frequency. These steps will result to vertical bar charts. Interchanging categories and frequencies in step 1 would give a horizontal bar charts. Let's have an example. The following table shows the number of admissions at a training institute for the months January to June. Construct a bar chart for the data. We have a table here with 2 rows. The first row is for category month, and the months are listed January, February, March, April, May, and June. The second row is the number of admissions, or we can say the frequency. The first is 100 for January, 150 for February, 300 for March, 250 for April, 200 for May, and 150 for the month of June. Here is the bar charts corresponding to the given problem above. Take note that this is our horizontal line, and the category month is listed in here. Also, this is our vertical line here, and the number of admissions or frequency is assigned here. The vertical line is numbered on some intervals from 0, 100, 200, and 300. We stop on the 300 because the highest frequency here is 300 only. Please observe that our rectangles here are of equal width and they represent each month with the corresponding number of admissions. The first rectangle here represents the month of January, and the height of the rectangle corresponds to the number 100 with respect to the frequency. The second rectangle is for February, and the frequency is 150. So the level here is between 100 and 200. The third rectangle is for the month of March, and this is the highest numbered frequency. The fourth rectangle is for the month of April, and the frequency is 250. You can see here that the level of the rectangle is between 200 and 300. The next rectangle is for the month of May with the frequency 200, and the height of the rectangle is on the level of the 200 frequency. The last rectangle is for the month of June with the frequency 150. We can see also that the level or the height of the rectangle is in between 100 and 200. So we are done with our bar charts for our example, and this is our final answer. Let's go now to pie charts. Pie charts or pie graphs are also used to represent the categorical data. This representation gives emphasis to the relative weightage of each category. In a pie chart, a circle is drawn and it is divided into sectors. Number of sectors will be the number of categories. The area of each sector is proportional to the frequency of the categorical variable it represents. These are the steps to construct pie charts. Step 1. Compute for the sum of all frequencies, denoted by n. Step 2. Find the percentage of each frequency, denoted by f, category by the formula percentage equals f over n times 100%. Step 3. Find the angle corresponding to each frequency category by the formula angle equals f over n times 360 degrees. Step 4. Draw the pie chart corresponding to angle and percentage of each item of the category. Let us see one example here. In a university, there are 400 students in the foundation program, 450 in the first year diploma, 350 in the second year diploma, and 250 in the higher diploma. Construct a pie chart for the data. It is advisable that we put the data in a table. I have here a table with 4 columns. The first column is reserved for the level, and the levels are foundation, first year diploma, second-year diploma, and higher diploma. The next column is for the frequency. There are 400 students in the foundation program, 450 students in first-year diploma, 350 students in second-year diploma, and 250 students in higher diploma. There are two additional columns, namely percentage and angle, that we're going to fill in the blanks for these two columns. Let's go now to step 1, and that is to compute for the sum of all frequencies. Taking the summation of this column, we will have n equals 1450. Step 2, find the percentage of each frequency category by the formula percentage equals F over N times 100%. Let's start with our first blank here. So we're going to use the 400, and that is the frequency of the first level, divided by the 1450, and then multiply to 100%. And the answer is 27.6%. We will copy this value on this blank, and here we go. For the second blank, 31%. We got this when we have this 450 divided by 1450 times 100%. The next blank is 24.1%, and that is when we have the 350 divided by 1450 times 100%. The last blank is 17.2%, and this comes from 250 divided by 1450 times 100%. After that, let us get the total of this column. We will have 99.9%, and this is equivalent to 100%. Now, let us go to step 3. Find the angle corresponding to each frequency category by the formula angle equals F over N times 360 degrees. Let's begin with the first blank here. It means, again, I'm going to use the frequency value and then divide by the N 1450 times 360 degrees. This is equal to 99.31 degrees. This value we will copy on this blank. So we have now this 99.31 degrees. Next, for this blank, we will follow the same formula. So we will get 111.72 degrees. We will get this when we have 450 divided by the N 1450 times 360 degrees. So the value is here. The next is 86.90 degrees. This value comes from the 350 divided by 1450 times 360 degrees. And the last blank is equal to 62.07 degrees. This comes from 250 divided by 1450 times 360 degrees. And the value is written here. Now let us take the summation of this column, and we will have the answer 360 degrees. This must be always equal to 360 degrees. On the same way that this column must have the summation that is equal to 100%. Now, let us go to step 4. Draw the pie chart corresponding to angle and percentage of each item of the category. So let us minimize our table because we're going to draw the pie chart. This is the finished product or the pie chart of this example. Please observe that in the pie chart, we are putting the percentage for each item of the category. Let's start with the first one, the foundation. So this 27.6% is written here. And for the angle, 99.31 degrees, it is estimated in the central angle. The next level is for first year diploma, which is 31%. And here is the 31% in red-orange color. And the central angle here is estimated to be 111.72 degrees. The third item is second year diploma with 24.1%. Here we go. And the angle is 86.90 degrees. And this is the angle. The last level is the higher diploma with 17.2%. And there we write the 17.2%. And the central angle is estimated to be 62.07 degrees. We can see here that our pie chart is colorful. However, in our daily class activity, what we can do is simply put each level opposite each corresponding sector. It means to say, the foundation program, we can write somewhere here. The first year diploma, we can write somewhere this side. The second year diploma may stay here. And the higher diploma, we can write somewhere here. And this is our final answer. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study histogram. A histogram consists of contiguous or adjoining boxes. It has both a horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents. The vertical axis is labeled either frequency or relative frequency or percent frequency or probability. The histogram can give you the shape of the data, the center, and the spread of the grouped frequency distribution. Here are the steps to construct histogram. Step 1. Compute for lower and upper class boundaries of each class interval. The formula is given. For upper class boundary, that is equal to UL sub C. This UL means upper limit of the class interval, plus LL sub n. This is lower limit of the next class interval all over 2. The upper class boundary of a particular class is equal to the lower class boundary of the next class. Step 2. Draw horizontal line and number it for class boundaries accordingly, and vertical line for frequencies. Step 3. Describe the classes by rectangles using lower and upper boundaries as width and frequencies as height, respectively. Let us see one example. For 108 randomly selected college applicants, the following frequency distribution for entrance exam scores was obtained. Construct a histogram for the data. We have a table here with 2 columns. The first column is for class limits or class intervals. We have 1, 2, 3, 4, 5 groups. The first class interval is from 90 to 98. The second class interval is from 99 to 107. The third is from 108 to 116. The fourth class interval from 117 to 125. The last class interval is from 126 to 134. The second column is for frequency. There are 6 observations for the first class interval: 22, 43, 28, and 9 for the other class intervals, respectively. We need 2 more columns, and these are lower class boundary and upper class boundary, respectively. Let us now solve for this first blank here for the upper class boundary, which is for the first class interval. The formula is given to us, which is upper limit of the class plus the lower limit of the next class divided by 2. It means to say the upper limit is 98 plus the lower limit of the next class, which is 99. So we see here 98 plus 99 divided by 2, we have 197 over 2, that is equal to 98.5. We will copy this value on this blank, and there we go. Next, it was stated that the upper class boundary of a particular class is equal to the lower class boundary of the next class. So we have 98.5 for this blank, which is the lower class boundary of the next class. Going to our upper class boundary of the second class interval, we will use the same formula. So we have 107, the upper limit, plus 108, the lower limit of the next class, divided by 2. This is equal to 215 over 2 equals 107.5. And this value we will write here. Again, this 107.5 we will copy down here as the lower class boundary for the next class. Then, let us compute for this upper class boundary of the third class interval. So we have 116 plus 117 all over 2. This is equal to 233 over 2, which is equal now to 116.5. And this value we will copy here. And this 116.5 will be same as the lower class boundary of the next class. Then let us compute for the upper class boundary of the fourth class. We have 125 plus 126 divided by 2, and that is equal to 251 over 2, and the quotient is 125.5. This value we will copy in here. Also, this 125.5 is the lower class boundary of the next class. And there we go. Then let us compute for the upper class boundary of the last class. We may use our same formula here. But did you notice a pattern here? Looking at the upper class boundary, it seems that the upper class boundary is equal to upper limit plus 0.5. Look at this 98.5. We can see that the upper limit is 98 and this is 98.5. It's like the 98 plus 0.5 will give the upper class boundary, which is 98.5. The same is for 107.5, that is 107 plus 0.5, we will get this value. And that is also true for this 116.5 and also for 125.5. It means to say, using that pattern, we can simply get the value for our last blank, the upper class boundary of the last class, and that is 134, this upper limit, plus 0.5, we will get 134.5 that we can write in here. Also, for the lower class boundary column, if we look at our lower limit, this is 99. It seems that this 98.5 is the result when we have lower limit minus 0.5. So you see, this is 99 minus 0.5 will give 98.5. Also, this 107.5 may come from 108 minus 0.5. This 116.5 comes when we have 117 minus 0.5. And the last, the 125.5, may come from 126 minus 0.5. On the same note, we can compute for this blank, for the value lower class boundary of the first class. We can get the lower limit 90 and then minus 0.5, and we will get this 89.5. We may copy now this value for our lower class boundary of the first class interval. Our table now is complete. Let us now write the histogram. First, let us draw the horizontal line and the vertical line here. In the horizontal line, we will write the class boundaries, and for the vertical line, we will write the frequency. Now let us describe the first class interval. Take note, the first class interval has lower class boundary of 89.5 and the upper class boundary is 98.5. So this is from this point up to this point in our horizontal line. So the rectangle corresponding to our first class interval is given here. The width is from 89.5 to 98.5 and the height is up to the level of 6 in the frequency. For the second class interval, we have the class boundaries from 98.5 to 107.5. So this is our interval, and the rectangle corresponding to that is this one with a height that is equal to 22 in the frequency. The third class interval has class boundaries from 107.5 to 116.5. And the rectangle for this class is given here with a height of 43 in the frequency. For the fourth class interval, we have class boundaries from 116.5 to 125.5. And the rectangle corresponding to this is given with a height that is equal to 28 in the frequency. For our last class interval, whose class boundaries are 125.5 and 134.5, the rectangle is given here with a height that is equal to 9 in our frequency. So this is our histogram now, and this is our final answer. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study frequency polygon. Let us define frequency polygon. Frequency polygon is obtained by joining the points by straight line plotted for the frequencies for each midpoint of the class. Midpoints are plotted along the x-axis and the frequencies to y-axis. The two endpoints of the graph are connected to the horizontal axis to make it as a closed figure. Let us see this example. Construct a frequency polygon for the distribution. This is the distribution. We have two columns. The first column is for the class limits. There are 1, 2, 3, 4, 5 classes. This is the column for the frequency. A frequency of 3 for the class 90 to 98. A frequency of 5 for the class 99 to 107. A frequency of 10 for the class 108 to 116. A frequency of 13 for the class 117 to 125. A frequency of 4 for the class 126 to 134. For our solution, let us do step 1, and that is construct another column for midpoints. This is the column for the midpoints denoted by x sub m. we're going to use the formula lower limit plus upper limit divided by 2. We know that for this class, the lower limit is 90 and the upper limit is 98. So for us to find the value for the first blank, we will write x sub m equals 90 plus 98 divided by 2. The sum of the numerator is 188, and this is now divided by 2. The answer is 94. And this value we will write here. For the second blank, the value is 103. That is 99 plus 107 divided by 2 equals, the sum is 206. Divided by 2, we will get this 103. The third value here is 112. That is 108 plus 116 divided by 2. The sum of the numerator is 224, and this is divided by 2, so we get 112. The next number for the midpoint is 121. That is 117 plus 125 divided by 2. The sum of the numerator is 242. Divide by 2, the answer is 121. The last value is 130. We got this from 126 plus 134 divided by 2. The sum is 260 over 2, so we get this 130. We are now done with the column of the midpoints. For step 2, we're going to plot the points. The midpoint is the x-coordinate, while the frequency is the y-coordinate. So we can see here, this is the x-axis, where the midpoints are listed, and for the y-axis, the frequencies are here. The first point is the 94, 3. So we have this point. The second point is 103, 5. This is the point. The third point is 112, 10. Here is the point. Next point is 121, 13. Here is the point. The last point is 130, 4. Here is the point. Next, let us connect these points with straight lines. Here now are the points connected by straight lines. Next, step 3 is to connect the two endpoints of the graph to the horizontal axis. It means we're going to add two more numbers of midpoints in the x-axis. One after 130 and the other one is before 94. Take note that the interval between midpoints is 9. So the first number here would be 85 and the other number here is 139. It's like we're adding another midpoints but with 0 frequency. Here are now the points, and we connect these points with the endpoints of the graph. This is now the frequency polygon. This is the final answer. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study measures of central tendency for ungrouped data. Let us define measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. There are three most widely used measures. The first is the mean, next is the median, third is the mode. Let us discuss the measures one by one. The mean, symbolized by this symbol, and this is read as x bar, is the sum of all terms divided by the number of terms. In symbol, we may write x bar equals sum of observations divided by total number of observations. In formula, we may write sigma x over n. The sigma is read as summation. So the formula here is read as summation of x over n. Let's have an example. The data represent the number of days off per year for a sample of individuals selected from 9 different countries. Find the mean. The values are here: 20, 26, 40, 36, 23, 42, 35, 24, and 30. Using our formula here, we will take the sum of all these numbers. So we have 20 plus 26 plus 40 plus 36 plus 23 plus 42 plus 35 plus 24 plus 30 all over 9, because there are 9 numbers here. Using our calculator, the numerator will be 276 over the same number 9 in the denominator, and simplifying this, we have 30.67, and this is rounded to 2 decimal places. This is our final answer. On the topic about mean, there is what we call weighted mean. When the data is given with frequencies, the mean can be calculated by multiplying each distinct value by its frequency and then dividing the sum by the total number of frequencies. In symbol, we may write x bar equals the summation of fx all over summation of f. Let us see how the formula will be used. Let's have an example. Find the mean for the following distribution. We have a table here with two columns. The first column is for the marks. We regard that to be x. The second column is the frequency with the symbol f. In the first line, we can see that the mark 45 has a frequency of 4, 30 with 1, 85 with 3, 90 with 5, 75 with 3 respectively. Next, we're going to take the summation of the frequency, and that is equal to 16. The next step, we need another column that says fx. This is the column of the product of the mark and the frequency respectively. It means to say we're going to multiply the 45 with 4. We will put the answer here, so on and so forth. So the first blank will be 180. 30 times 1 is 30. 85 times 3 is 255. 90 times 5 is 450. 75 times 3 is 225. And then at the bottom, let us take the summation, and that is equal to 1140. So these values, summation of this column, also of this column, are the ones needed for our formula. So we have x bar equals the summation of fx is 1140, and it is now written here, over the summation of f is 16. Then simplifying, getting the quotient, we have 71.25. This is our final answer. Let's have the second measure, and this is the median. In books, we can see the symbol as capital M, D, N for the median. As defined, median is the middle value that divides the ordered data from smallest to largest into 2. We're going to use this formula, MDN equals n plus 1 over 2. But take note that this formula will only describe the position of the median. If n is an odd number, the median is the middle value of the ordered data from smallest to largest. If n is an even number, the median is equal to the two middle values added together and divided by 2 after the data has been ordered. Let us see some examples. Example 1. Find the median of these values: 684, 764, 656, 702, 856, 1133, and the last is 1132. First thing to do is to arrange the data from smallest to largest. So the first value will be 656, next is 684, followed by 702, next is 764, next is 856, then 1132, and the last 1133. Take note that n, or the number of data, equals 7, and this 7 is an odd number. Let us now use our formula here. So median equals, the n plus 1 is now 7 plus 1, taken from here, the number 7, over 2. Simplifying this, 7 plus 1 is 8 divided by 2, and this is equal to 4. This number 4 here describes the fourth value of our arranged data. So, finding the fourth value, this is the first, second, third, and the fourth. The 764, that is the median. This is our final answer. Let us have example 2. The number of guest rooms of 10 hotels in Muscat are 71, 30, 61, 59, 31, 41, 47, 64, 23, and 22 respectively. Find the median. First, let us arrange the data from smallest to largest. So we have 22 as the first term, followed by 23, next 30, then 31, followed by 41, next is 47, and then 59, then 61, followed by 64, and the last is 71. Take note that our n equals 10, and this is an even number. Using our formula now, we will write median equals 10 plus 1 over 2. And 10 plus 1 is 11 divided by 2, and this is equal to 5.5. And this is the 5.5 value of the ordered data. Take note that this is between 5 and 6. So we identify the 5th and the 6th values respectively, 41 and 47. What we're going to do is to get the sum of these two values and divide by 2. So we have 41 plus 47 over 2. This is equal to 88 over 2, and the answer is 44. This is our median. Take note, the median 44 divides the ordered data into two groups. The first group is below the median, and the other group is above median. This is our final answer. Let's go now to the third measure, and that is the mode. Some books give the symbol MO for the mode, and this is defined as the value that appears most frequent in the data set. A distribution with only one mode is said to be unimodal, while with two modes is bimodal, three modes is trimodal, and so on. Let's have example 1. Find the mode for the following data. Let us simply observe which value appears most frequent. We can observe that this 120 appears 3 times. There is another value, this 110, appears 2 times, while others appears only once. In this distribution, the mode is 120. This is our final answer. Let us have example 2. Find the mode for the following data: 110, 131, 103, 184, 112, 197, 113, and 122. We can see that each value appears once. In this case, we will write there is no mode. Take note, do not write mode equals 0, because this 0 is a value that may be part of any data. So this no mode is our final answer. I hope you learned something from this video. See you again next time.